Good afternoon, everyone. Today I am presenting my project titled Student Marks Analysis System, a lightweight yet complete analytics tool built using only two powerful Python libraries, NumPy and Pandas. The goal of this project is to analyze student performance efficiently without relying on heavy frameworks. The entire system focuses on simplicity, speed, and accuracy. We start by loading the data. The system automatically reads a CSV or Excel file, and if no file exists, it even creates a sample marks dataset. This ensures the program always has valid input. After loading the data, the next step is initial quality checks, displaying the head of the dataset, verifying the data types, and identifying missing values. These checks help confirm whether data set is clean and ready for processing. Next, we move into data cleaning and preparation. The system removes duplicates, converts incorrect data types, and fills missing values using column means. This imputation method ensures that the overall score distribution remains balanced and accurate. After cleaning, the dataset becomes fully reliable for further analysis. Once the data is ready, we calculate key metrics. These include each student's average score across math, science, and English, along with total marks. We also compute subject wise maximum and minimum values and detailed statistical summaries using NumPy, such as mean, median, and standard deviation. These statistics help us understand the distribution and consistency of scores across subjects. We then move into class wise analysis. Using Pandas group by, the system generates insights such as average performance per class, subject wise trends, and student counts. This is extremely useful for teachers to identify which class is performing well and which ones may need academic support. After this, we identify top performers. The system extracts the highest scoring students overall as well as in each subject, giving teachers a clear view of excellence within the data set. Alongside this, we implement a simple outlier detection mechanism. Student whose averages falls below mean minus 2 standard deviations are flagged as at risk. This allows early detection of students who may need additional help. The system also supports basic visualizations. If matplotlib is installed, it generates histograms of average scores and bar charts of top performers. These visuals help in quickly understanding patterns and presenting insights to teachers or institutions. Finally, all processed data and summaries are saved into an output folder, including the cleaned data set, class wise summaries, and the list of top performers. A final printed report summarizes the total number of students, subject averages, overall performance, and count of at risk students. In conclusion, this project demonstrates how much can be achieved using just NumPy and Pandas. It covers the complete pipeline: data loading, cleaning, analysis, insights, visualization, and reporting, all in a simple, efficient, and easy to use format. This makes it ideal for teachers, schools, and academic analysis tasks. Now, we shall go ahead with coding. Open your VS Code or Google Colab and code along with me. I am going to walk you through a complete student marks analysis system built using Python, Pandas, and NumPy. I will explain every single line from dataset creation, cleaning, analysis, grading, visualizations, and exporting output files. By the end of this video, you will clearly understand how a real world student analytics system works end to end. So let's begin. Here at the very top of the script, we have a multi-line string or doc string. This is not executed by Python, but it acts like a documentation block. This tells us what the project is: a complete student marks analysis system. Here I am explaining that the script is smart enough to auto-generate data if you don't already have a file. So the script basically behaves like a mini backend system. Imports. Next, we import the libraries needed. I am importing OS for file handling, NumPy for math operations, and Pandas for data handling. Constants. These two variables simply store file names that we'll load or create later. Function. Create sample CSV. Now we create a function called create sample CSV. This function will create 50 rows of student data. The random state ensures that the same random values generate every time. Generate student names. I am creating a NumPy random generator called RNG. Then I create 50 student names like student 1, student 2 up to student 50. Generate classes and gender. I generate random class values 6, 7 or 8. Then I randomly assign gender, male or female, to each student. Generate marks. I use a normal distribution to generate marks with an average around 70 and standard deviation of 12. Clip ensures the marks stay between 0 and 100. The same is done for science and English. Inject missing values. I randomly select about 10% of rows to make some marks missing. Half of them get missing math marks and the other half get missing English marks. Create data frame. I now create a Pandas data frame with all the columns. Save the file. This writes the dataset into a CSV file. Auto create CSV if not exists. This checks if both CSV and Excel don't exist. If not, it creates the CSV. Otherwise, load data function. This function loads the CSV or Excel file. So first, it checks if the CSV exists and loads it. Otherwise, it loads Excel. If neither exists, it raises an error. Basic data checks. I print the first few rows. This shows the data types and counts. This prints numeric statistics. Remove duplicates. This checks if any duplicate rows existed and removes them. Convert columns to numeric. I define what numeric columns we want. This ensures marks are treated as numbers. Missing values. This counts all missing values. Fill missing values. This replaces missing marks with the average mark. Compute averages and totals. This calculates each student's total and average marks. Subject statistics. This gets the highest and lowest marks in each subject. NumPy statistics. I calculate mean, median, standard deviation, minimum, and maximum for all subjects and averages. Assign grades. This function assigns a grade using a simple grading scheme. I also mark whether the student passed. Group by class. This gives class-wise averages, medians, and subject means. Top performers. This gives the top 5 students with the highest averages. Outlier detection. Any student below this threshold is marked as at risk. This is based on statistical outlier detection. Visualizations. These sections generate histograms and bar charts if matplotlib is installed. Saving output files. I create an output folder. I save the cleaned processed data set. Final report summary. This prints a final report at the end of execution. Come on, let us execute this code now. Click the play button to get the output. And we have the derived output. So a sample data set is created and saved to marks.csv. Loaded data from marks.csv. So there are a total of 50 entries. So there are a total of 50 entries with 7 columns. Student ID, name, class, gender, and the rest make the 7 columns. So those 50 entries are 0 to 49. We have the data type, we have the non-null count, and the 7 columns. Here we have the numerics values of class, math, science and English. We also have the missing values per column. So as we can clearly see, we have 2 missing values for math and 3 missing values for English. So for math, it is filled with mean 68.04. For science, it should be filled with mean 66.64, and for English, it should be filled with mean 65.98. Then we have the subject maximums for math 88, science 100 and English 97. Then we have the subject minimums for math 50, science 38 and English 40. These are all the computed statistics using NumPy, math, science, English and average. We have mean, median and standard deviations calculated. Here we have grouped by class. So class is 6th, 7th and 8th grades. We have their respective average mean, average median, average count, math mean, science mean as well as English mean. We have the top 5 overall students, student 41, 42, 28, 0 and 9. We have their student ID, name, class, average and their secured grade. Then we have the average mean calculated, standard deviation and at-risk threshold as well. And with the help of matplotlib, I have also created visualization techniques so that it makes it easier to analyze the graph. So here I have average score on x-axis and frequency on y-axis. This is the distribution of students' averages. And then here I have top 10 students by average. X-axis I have name and then average scores I have on y-axis. These are the respective students. So ultimately all the saved processed data and summaries are saved in the output folder. We have a report summary here. So the total number of students are 50. The subject means we have math, science and English with the respective numbers, that those are the respective means. Overall average mean is 66.89 and the number of students who are flagged at risk, and all the saved outputs are being stored in these 3 CSV files. So, and with that, the complete student marks analysis system script ends. It automatically generates data, cleans it and analyzes it, finds the top students, detects at-risk students, visualizes the data and finally exports everything neatly. Thank you so much for watching this deep dive tutorial. If you enjoyed this video, hit the like button, subscribe to the channel and share it with your friends learning Python, data science or machine learning. See you in this next session. Do not forget to subscribe to the channel. Thank you.